Hello, Math Studies students, and welcome to your online lesson. Today we will learn to factor quadratic equations with no A-term values, just like we saw in the previous video lesson, but this time we'll also introduce negative values for both our quadratics as well as our possible answers. We will know we are successful when we can efficiently factor quadratics to create two binomials. Quick reminder, a quadratic equation is one that has an x squared in it. It can also have just an x with a coefficient, it can have constants, and for an equation it's got to have equal something, and usually we set them equal to 0. Quadratic expression, again, it's going to have an x squared term. X is going to be the highest, or x squared is going to be the highest exponent that we have. We won't have any cubes or x to the fourth or anything like that. And again, we can see a term with just an x and a term with a constant. So usually 3 terms. We'll be focusing on problems that have no value for a here today, just like our last video lesson. And so there's an implied 1 there, but we will have values generally for our b and our c. Factoring, sometimes referred to as factorizing an equation or an expression, is essentially undoing a binomial distribution. We looked at that in the last video. And so again, we should be getting binomials as our answer in most cases. Quick reminder on the steps that we'll be using to do this. Again, we want to check to make sure that we have a quadratic. It should have an x squared term. We'll be focusing a lot on this constant number, which we refer to often as c, and our coefficient of x, which is b. We're going to list the pairs of factors that can multiply to be the c term. Again, factors are numbers that, as it says, multiply to be a number. So two whole numbers that multiply to equal our c term. Then we're going to look at those factors from step 2, and we're going to find which ones can be added to equal our b term. So again, which numbers that multiply to be c can then add to be b. And then we're going to take those numbers and we're going to throw them right in here into this form so that we end up with 2 binomials, x plus one number, x plus another number. Except this time around, our numbers might be negative. So in fact, we'll actually have plus a negative, or better yet, we can just write that as x minus the number, or if it's positive, we can leave it as x plus the number. And as always, we can check our work when we're all said and done to see if we get back to the original equation. And we'll do that for at least one of our examples here on this video. So now what's new? What's new is we're going to be looking at some quadratics that have negative values in either the b or the c terms. Now, if there's no negatives anywhere in the quadratic expression, like our last video lesson, we're going to end up with all of our factors of c being positive. And that means we'll have x plus some number times x plus some other number as our actual factors that we plug into our binomial. However, if only the b term has a negative sign, implying that the c term is positive, but just the b is negative, then that implies that both of our factors of c will be negative, because we'll need 2 numbers that multiply to be c, and c is positive. And again, a negative times a negative will give us a positive, but then those 2 numbers will then add to be our negative b. So once again, if b has a negative sign but c is positive, we know that both of our factors, both the numbers that we're going to plug into our binomials, are both going to be negative. And then finally, if the c term is negative, like we have in both of these examples here, the c term has a minus sign in front of it, then you'll end up with 1 positive factor and 1 negative factor, which is good to know. But better yet, we will also know that the larger value will have the same sign as the b term. So if we look at this quadratic right here, something in this form where the c is negative, we know we're going to have 2 factors, that are, one that's positive, one that's negative, but the bigger of those 2 numbers, its absolute value of the bigger of the 2 of those numbers, will be positive. And then if we look at this example here, again, we can see our c is negative, so we're going to have 1 factor of c that'll be positive, 1 that's negative. But if we look at the overall absolute value of those numbers, the one with the larger value will be the negative one, because that is what our b term has the sign of. Now, some of this might be a little bit confusing in words, and so good news, we're going to look at some examples next. So, unlike our example from last video, we have negative signs. And this one actually has a lot of negative signs. It's got a negative in front of the b, and it has a negative in front of the c. Well, I like to start with the c, actually. If the c is negative, already I know there's going to be 2 different signs in our factors, meaning one's going to be positive and one's going to be negative. And if we go through our steps of factoring a quadratic, the first thing is we look at this c term and we have a negative 24. Remember to keep that minus sign with the 24. So minus 24 is the number that we're going to try to factor first. And so I like to start at the very beginning. I have a 1. 1 goes into 24 times. Now I check 2. 2 also goes into 24, but 12 times. 3 also goes into 24, 8 times. 4 goes into 24, 6 times. 5 does not go into 24. And the next number I'd be checking is 6, but I already see that's one of my factors, so I don't need to continue on. All right. Now, up to this point, I've been ignoring the fact that it's a negative 24. I've just been looking at an absolute value of 24. Because the other thing that I remember from that last slide is we know that when that C term again is negative, that I'm going to have one that's positive and one that's negative. But the bigger of those two numbers is going to have the same sign as this B term. And my B term is negative, which means the bigger of my two numbers has to be negative. So my right column here, negative 24, negative 12, negative 8, and negative 6 are going to be the way that I'm going to indicate all of those, because I have to have more negative than positive. Now, how do I know that, or why is that a rule? It's because when we actually add these together, whatever you have more of, more positive, more negative, that's what your answer is going to be. So for example, when I add these together, 1 and negative 24, I end up with negative 23. Essentially, we're subtracting and keeping the sign of the larger. 2 and negative 12, again, 12 minus 2 is 10, but we had more negatives than positives. Again, the sign's different here. 3 and negative 8, keep the sign of the larger. 8 minus 3 is 5, so we have negative 5. And last but not least, negative 6 and 4 gives us negative 2 when we add those together. Now what I'm looking for, and I'm going to clean up my equation over here, so I'm going to check to see which one of these pairs of factors I like. And obviously our B term here was the negative 5, so I like this one right here. So again, we're writing our binomial factors here. I've got x, and I've got an x here. And now I'm just going to keep the sign of whatever we have. And since we like this one here with the positive 3, I'll write plus 3, and I'll write minus 5. Order doesn't matter. We could have written x minus 5 and x plus 3, but the signs do matter. The positive has to stay with the 3, and the negative has to stay with the 5. And I kept saying 5, but actually I should have been writing 8 this whole time. So it's a plus 3 and a minus 8. Sorry for that error. And again, I knew that because I was already doing a mental check, and that's what we can do next. So this is actually our answer here. I'm going to put a little star next to it. That's our answer, but we can check this answer now by actually doing some FOIL or super distribution. If I take my x times my x and my x times my negative 8, I end up with x squared, and then I end up with a negative 8x. Now I can do the same thing, but this time with my positive 3, distribute that to the x and distribute it to the 8. 3 times x gives me positive 3x, and 3 times negative 8 gives me negative 24. Now I can combine these middle terms here because they both are like terms. They both have x's, and I bring down my x squared. Negative 8x plus 3x gives me negative 5x, and then finally negative 24. And if you compare this to what we started with, they are exactly the same thing. Now, just to clarify, what is our actual answer? It's not what I wrote in green. It's not the check. It's the original binomials, x plus 3 times x minus 8 that we had here in red, right where I started. All right, let's take a look at another example. All right, so this time I've got x squared minus 6x plus 9. The c term this time is positive. And if everything was positive, I wouldn't have to worry about negative signs at all. I would just assume that every single one of my factors is going to be positive. However, the b, and only the b term, is negative, which means that I will have to add these factors together to equal a negative number, which means they both must be negative, because two negatives can multiply to be a positive, but then add to be a negative. So I'm going to start listing my factors here. I've got 9. But things multiply to be 9. Always start with 1. 1 and 9. 2 doesn't go into 9. 3 goes into 9 3 times, and I've already caught up to essentially itself because I have 3 in the right-hand column, which was the highest number I had in the left, which means I don't need to go any further. But if you don't believe me, we can check. 4 doesn't go into 9 evenly. 5 doesn't go in evenly. 6, 7, 8, all of which, and we already had 9 as one of our factors. So now the question is, what sign are they going to be? Well, as we said before, since only the b is negative and the c is not, they are both negative. And the reason for that, if I take this first pair and I multiply them together, I end up with a positive answer. Negative times a negative gives me a positive, and 1 times 9, of course, gives me 9, which is what we were originally looking for. Now, what we want to actually check, though, is which one of these will add to be our negative 6. And so if I'm adding these, a negative 1 plus a negative 9 gives me a negative 10. And then when I add this next batch together, I end up with negative 6. And of course, we want to have a negative 6 because that is what our b term was. So I write my parentheses here, x for each one of those binomials, and then I plug in my values. And again, we decided, sorry for the earlier circle, we don't want that. We want this one because it added to be this negative 6, which is what we had as our b term. So we have an x minus 3 again. Interesting thing about this one, you'll notice that both my binomials are exactly the same. And there's a pattern that we'll talk about perhaps in another lesson where you can identify that ahead of time. But I can write this in a more simplified way. I have x minus 3 times itself. And how do we write something times itself? Squared. So that's perhaps a better, more simplified way of writing it. Now, I certainly wouldn't mark off if you were to put something like this on a test, but we have to be aware that this is the same thing, especially if we're looking at like a multiple choice test or something along those lines, which would never likely appear on an IB exam, but you get the idea. Last example for today. One thing I want to point out is we have an equation now. How do I know? Because there's an equal sign here. But I'm not going to do anything differently. In fact, I'm literally just going to ignore that equal sign. And at the very end, or actually I could do it right now, I'm just going to write equals 0. I'm still going to have 2 binomial factors. I'll have an x in each one of those. And then my factors will be determine whether I have a plus or a minus, and then the factors of negative 48. So let's start with my c term. This time my c term is negative. So I have a negative 48 here. And unlike the last one, or the first example that we had, this time my b term is actually positive. So my last term, my c term, is negative, which means that one of its factors has to be positive, one of them has to be negative, and yet the bigger one has to be positive. And I'll show you what that means in just a second here. So we'll just take, again, our factors for 48, ignoring the negative at first. So I've got a 1 and a 48. 2 goes into 48 24 times. Again, if you're unsure about these when we get to these larger numbers, you can always just type into a calculator 48 divided by, and then whatever the number is that you're checking. So if I'm checking a 2, we divide by 2, and the calculator will spit out 24. If it spits back a number that's not a whole number, then we don't have a factor, and you can move on to the next digit. So then we can try 3, and 3 goes into 48 16 times. 4 goes into 48 12 times. 5 does not go into 48. 6 goes into 48 8 times. 7 does not go into 48, and then I'm already back to this 8 here, and so I have checked every possible whole number up to 48, essentially. All right, now, what sign are we looking at? As we said before, the c term is negative, so I have to have one of each in order to multiply and equal that 48, but we said our b term is actually positive. We have a positive 2 here, which means I need to have more positive than negative, so the positive numbers will be our bigger ones. So our right column will stay positive, and our left column is going to get all the negatives. And now we can check these. Now, you don't need to add every single number together. As I go through this, I could have 48 and the negative 1, which gives me 47, and moving on. And it doesn't take that long to do these, but we only had 2 right here. Since our signs are different, and they're essentially 2 apart, we might want to just jump right to one of the ones that seems like it might be pretty close, the 8 and the negative 6, which of course does give us positive 2. And so these are going to be our factors that we plug into our binomials. We have x minus 6 and x plus 8. I again just brought down my equal sign here, brought down my 0. I didn't need to do anything with those. On a later lesson, we'll actually cover what to do with those to solve for x. But for today, that's what we're looking at. So that was our last example. Again, we looked today at factoring quadratic equations with no a term value, but with negative signs mixed in, building on what we saw in the previous lesson. Till next time,